All right, good. Okay, so we've added our lone pairs on the oxygen and the formal charge on the nitrogen. Now, when we try to draw resonance structure, the first thing that I would do is look at where the electron wants to go. Remember that electron wants to go where there is a lack of electrons. So in this case, nitrogen is positively charged, so it wants to receive electrons. And whenever we draw resonance structure, I always tell my students there's two ways that you can do this. Either by starting with pi electrons and sending the pi electrons towards an atom or a bond. This is option one. Or you can also start by electron pairs, and you can send the electron pairs to a bond. So in this case, we want to bring the electron to the nitrogen that is positively charged, and we have a double bond here. So what we're going to do is we're going to take those electrons from the pi bond and bring it to the nitrogen. So if we draw this first resonance structure, it gives us something like this. So we draw the rest the same way, we did not change it. Now we have those two electrons on the nitrogen, which now makes it neutral, and the carbon here lost one electron, therefore we give it a positive charge. All right, now you can do the same thing with the second molecule, where you're trying to bring electron to the positive charge on the carbon. And now, as you can see, we have oxygen next to it. So the two lone pairs on the oxygen will give the electrons and bring it into that bond to make a pi bond. So this is this example here. So if we draw that structure, right, one of the lone pairs still remains on the oxygen, and now this oxygen will have the positive charge. And finally, we can do the same thing again. We want to stabilize that positive charge. We have another doublet here on this other oxygen, so we can push the arrows this way. Remember that you cannot form 5 bonds on a carbon, so if we push this first arrow, we have to push a second arrow because we cannot have 5 bonds on carbon. So if we draw the product of this, it will be the following. Now, that terminates the first part of the question, which is to draw the resonance structure. Now, a bit more tricky is determine which is major and which is minor. So there's 4 rules to determine this. And in priority, what they are is the following. So first, you want to look at the number of incomplete octet. Second, you want to look at the number of charges. Third, you want to look at the position of the charge. This is true when you have one charge in your resonance structure. And fourth, you want to look at the separation of the charges. This is when you have 2 charges. So let's look at all of our molecules here and look at priority number 1 is the number of incomplete octet. So let's look at the first molecule. All of the octets are complete. The nitrogen here, even though it's positively charged, it has 8 electrons around it. So here we'll say the octet are fine. If we look at the second structure, we can see that this carbon here only has 6 electrons around it, and it is positively charged. So here we are missing, we have 1 incomplete octet. On this structure here, the third one, we have a full octet again. You can count for yourself. And same thing for this last structure here. So this tells us that this compound here, the second one, is the minor. The least stable, yes. All right, so that's priority number 1. So it's the first thing that you should be looking at. Then 2 is the number of charges. In this case, all of the structures that we drew all have 1 charge, so we can't use this priority rule. Then we go to rule number 3, which is the position of the charge. Here we have 1 charge, so we're going to be following this rule. If you have 2 charges, you look at the separation of the charges, but we don't have that today, so we can ignore that. So the position of the charge. So if we look here, we have the positive charge on the nitrogen. Here we have the positive charge on the oxygen. So remember that we want to put a negative charge on electronegative atom. And we want to put positive charge on less electronegative atom. So in this case, we know that on the periodic table, oxygen is to the right to the nitrogen, so oxygen is more electronegative, nitrogen is less electronegative. Therefore, we want the positive charge on the nitrogen. It's going to be more stable. So that's why this compound here is major, because the positive charge is on the nitrogen. And finally, these 3 are actually the same structure because it is symmetrical. So this one gets number 3 because gets number 2 and 3 because the positive charge here is on the oxygen. All right, so this is how you answer this question.